A little bit about myself. I'm, as Valerik also very well mentioned, I'm an Android engineer by day. I've been doing this for quite some time, and I'm working at Greener Pastures. This is a mobile development agency where I'm doing Android development as well as being managing director there. Over the years, we've been working with different types of projects. So we worked on projects for startups, on projects together with enterprises, worth like billions of dollars in valuation. So we've gone through like different types of projects over the years, and each of them has had different challenges, unique perspectives, unique ways or requirements. And out of those, we've learned a lot, and that's why that's what I'm trying to share here today. A couple of the tips and tricks, especially the newer ones that have been around the Android development world recently. To start with, we'll be discussing a bit about project setup and how to make builds optimal. You've probably all seen this joke somewhere before, and while this is true for all kinds of, like for all of us developers, it's especially true for Android. Because projects need a lot of things to compile, they take a lot of time. For example, on one of our biggest projects right now, on a latest generation laptop, it takes about 18 minutes to build, to make a clean build. So if we can do something about this and optimize this, then definitely it's going to make our lives much, much happier. So as you probably all know, Crashlytics is something that is a must for real-world applications, and especially for going to production. However, it's doing all these magical tricks, and for this, it actually needs to do some extra steps during the build configuration process. And this is somewhere where we can actually do some optimization, especially since us as developers, like while developing, there's hardly a need for running Crashlytics and making sure things work correctly. For this, one of the first optimizations we can do is to make sure this the mapping file that they prepare and they upload to their servers actually doesn't get uploaded during debug builds, because this is going to save us a couple of seconds for sure. Secondly, after the switch from Fabric Crashlytics to Firebase Crashlytics, which is used these days, by the way, we kind of have to use a manifest attribute. This is the right way to do it correctly from the first run of the application. And here we can make use of manifest placeholders. These are some sort of variables that we can actually use. As you can see here, this Firebase Crashlytics collection enabled variable, we can use them in the manifest, and then we can define them easily inside the build Gradle file. This allows us, for example, to set it to false for debug builds. And of course, we should make sure that this is set to true on production builds, on the release builds. Moving forward, another aspect is that during development, sometimes we're iterating really fast. So we might end up running the application once a minute or like very, very often. And for this, we're typically using the same Android device. While this is definitely not recommended in the large scheme of things, like we should try to test on as many devices as possible, sometimes we want to iterate really fast. And for this, we can ask the Android compiler with Android Studio to just build the configuration for the device we are having, thus speeding up the build consistently, because it doesn't need to process all these resources. However, all these optimizations are usually something that come via observation. And this is why probably the first and the most important step is to profile our builds. And this is something we can do with the Gradle profiler that's embedded in the tool. So as you profile your build, first you should perform a clean, because each build after each build, Gradle doesn't recompute all tasks if some of them haven't changed. So the first step in profiling is to make sure that we start from a clean state. Then we should execute a debug build of the product flavors, such as dev or flavor in this particular case, with the following flags. So first of all is profile. This actually enables the profiling. Then we can make use of offline. This disables Gradle from fetching online dependencies, and such makes sure that any delays that are caused by Gradle are not due to the network, they're actually due to the tasks that we do in our project. Lastly, the rerun tasks kind of forces Gradle to run all the tasks in our build steps. Once this happens, we end up with a profiling report that they prepare for us. This is somewhere in the build folder, in the build/report/profile, as far as I remember, and you end up with a HTML file such as this one, where you can actually see how much time it took to run each of the tasks. There's a lot of nice information in there, and you can drill in deep into some areas, and you can figure out usually what are the parts that are causing most of your build time to run. And for example, you can do a lot of optimizations, especially for CI/CD systems or for your own machine. All right, moving a bit in a different direction, moving away from profiling and to how we should write our code. Let's talk a bit about dependency versioning. This is something that probably all of us is familiar with, how we provide versions for the different artifacts and dependencies that we use, especially on Android, where we kind of need to use quite a few. We've tried over time different approaches, and the one we've settled for is the one that you can actually see here, where we make use of build of Gradle variables that we define by the X block, where we actually, inside this variable, we store the entire dependency, including the artifact as well as the dependency. The benefit of this compared to just putting the version in here is that someone can simply read here and see what the full dependency is. If a change is needed, we can just change the version, or we can also change the artifact. We have a one place where this is configurable. And also, as we'll see a bit later on, this also has a really nice benefit when it comes to writing it down. We can also make use of versions or variables for the versions when we're discussing dependencies such as retrofit, which actually comes with multiple artifacts. In order to keep these artifacts in sync, the recommended approach would be to define a private, quote unquote, variable that stores the version for that particular dependency. And then inside the a namespace, we can actually also use this mapping of Groovy in order to basically group the sub-artifacts that are related to retrofit, and also we can use the retrofit version in there. And this kind of also has two big benefits. One is that we keep the versions in sync, so we have the 2.8.1 version for all the artifacts, and also the artifacts are namespaced. Moving forward, especially with Android X, this is really true. We might have some benefits from namespacing at multiple layers, and we can easily use this pattern to do nested namespacing. All right, so we've chatted a bit about how we can define these dependencies. Let's see how they get used. So in practice, the upside is that in each of these, the modules, or in each of the modules of the project where you want to use these dependencies, we can simply write something like implementation timber or implementation retrofit.core and retrofit.json, and everything is much more clear. I think it's a bit more readable. And the big advantage, especially in multi-module projects, is that we have a single place where all the dependencies are listed. When we do an update, we are guaranteed to have the same version running all over the project. And it's also quite nice to read. I can also, the last example here shows how the double namespaced example works as well. So this has worked really good for us. One of the projects we're working on has about 40 sub-modules, and this is the approach we're using there in order to keep things easily maintainable and consistent across modules. Moving forward, there comes Firebase, also related to the versioning discussion that we've just had. So a while back, at the beginning, actually, Firebase was versioning all the dependencies with the same number. So it was version Firebase 18, and all the libraries in there had version 18. Then they switched to this approach where each of the dependencies comes with a separate versioning number, which is nice because it gives the advantage of being able to have a good resolution when it comes to doing updates. But it also comes to the hassle of knowing which version you should use, also the compatibility between them. So, for example, Firestore might require an auth version of at least 19.3 or something along the lines of that. So this has actually become more and more complex, especially over the past months. And this is also becoming quite true a bit about Android X as well. And this is where the Firebase BOM system works. So BOM comes from bills of material, and it's a feature of Gradle, which allows us to specify a single version at the top of the file. In this particular case, when we use the Firebase BOM in the app, this automatically pulls in the individual library versions mapped to the BOM's version. each of the individual libraries in here will be compatible. And the advantage is that whenever we update the BOM version in our app, all the Firebase libraries that we use will update to the versions mapped to that particular BOM version and also maintain compatibility. This, as you can see here, instead of basically spacing, like adding the version for the particular artifact, we don't do that anymore. The version comes from the initial, the BOM version. However, as you can imagine, this could also pose problems when we need to make sure our apps is still compatible. We need to analyze the incompatible changes. So whenever a library updates, we kind of need to make sure we update our code. So we need to know what has changed between each of these Firebase BOMs. So the advantage is that they've, at least for Firebase, they've made a nice compare tool where you can actually set your initial version of the BOM file and the latest one that you're updating to. And after hitting compare, you'll get a list of only the libraries that have changed. So for example, you could see that only Firebase and Auth have changed, and then you go there like to read the change logs just for those. So this comes with a with a nice advantage. Moving forward, this is also related to the build Gradle file, and it goes into the topic of security and confidentiality. Passwords and sensitive information should never be stored in code. So for example, putting our store password or our key password in the Gradle file is definitely a security issue, because this usually goes to code, to the source code tools, to the version control systems, and those actually could be hacked. And there have been many examples where companies have been hacked, and people have used this information for malicious purposes. So this is something we shouldn't do. Then the question comes, like, what's the right approach for doing this correctly? Well, I think the right approach is to go for Gradle properties. If we make a Gradle properties file, this shouldn't be added to the version control system. This file is automatically imported by Gradle. So anything we specify in here is usable in the code, such as this. Basically, we can use the variables defining Gradle properties to provide the password in the build Gradle file. The Gradle properties shouldn't be committed. And furthermore, the other very nice benefit is that it can actually be appended with more properties from the CI/CD system. So for example, if you are using a CI/CD system and that's the one that keeps the passwords, the CI/CD can just write them inside the, append them to the Gradle properties file, and then basically we can make use of them in the Gradle tool. One other nice trick that you can use here is that because Gradle is built in Groovy, we can actually use try-catch blocks. So we can do something like this in order to catch any issues with the configuration. So throw a more meaningful exception. Yeah, the message should be longer, but it didn't fit on my slides, so we'll just stick to missing in Gradle properties here. But the advantage is that you can definitely try catch as an area and make sure that the consumers, like whoever's running the build, knows what's being wrong. All right, so we've moved quite fast through some of the build Gradle optimizations, and I really hope some of these are useful for you, and you'll make use of them in your projects moving forward. Then I also have a couple of tips when it comes to code, basically actual Android development and things to do in there. So first of all, as long as we are human, we all know that we are bound to make mistakes. So how do you know and correct our mistakes during Android development? Well, Android actually provides a tool just for this. Strict mode is a developer tool which detects things you might be doing by accident and brings them to your attention so you can fix them. This is most commonly used to catch accidental disk or network access, or leaking objects or closable objects, and so on, but not only. The right way to do it is just as you can see here. Basically, we can enable it. I would suggest you do this only on the build, the debug builds, or like the development builds, so this doesn't go into production. And during this detection, you can specify which are the checks that we want to make. VM policy applies to all threads in the virtual machine, while thread policy applies to a certain thread. After specifying these checks that need to be detected, we can also specify what happens when one of these problems is detected. And we can, for example, log this to logcat, and we'll be able to see what's going on in there. Or alternatively, we can just kill the app, or like show a dialog or something along the lines of that. All right. Moving forward, we've all heard that parse-level is the right way to pass information between fragments, for example, and indents, bundles, and so on. And this is definitely something that we should stick to, like use parse-level, never use serializable or other approaches for passing into things. However, at the same time, if you've ever written a parse-level code, you've seen how horrible this is. So I really like this quote that life's too short to actually manually write parse-level code. And this is where Kotlin comes in, actually. So as of a couple of versions back, actually, this is not quite a recent trick. There's a @parselize annotation that we can use. Basically, just by adding this to a class that implements the parse-level interface, the parse-level implementation gets generated automatically. Furthermore, enums can also be parcelized, and this is similar to parcelizing the data classes. And also, this works really nicely when we have a parcelable class that's embedding a parcelable field. Lastly, sealed and abstract classes can also be parcelized. And for this, the rule is that the parent class needs to implement the parcelable interface, and then we need to make sure we mark each of the child classes with the @parselize. This would help Kotlin know how to parcelize each of them, and we end up with a very nice parcelable sealed class. Moving forward, the right way to do this is the only thing that we need to do this is that we need to make sure the Kotlin Android extensions are enabled inside the build Gradle file. All right. The next topic is resources, and this is where we'll be chatting a bit about some of the interesting approaches that you can use in your apps, and some of the tips and tricks that we've kind of stumbled upon over time, and actually the patterns we are using in most of our projects today. So to start with, we can go for the first rule is to always split the style files by semantics. Now, otherwise, you risk having a huge file with like a few hundreds or maybe thousands of lines of styles. And also, it's really hard to go through them and analyze what's going on. So, for example, you can have a general styles file or like a styles widgets file where you can define the styles for your widgets. You can have a styles file for your text where you define your text appearances and so on. You can split them in as many files as you can, and things will work correctly. Furthermore, you can also put them in submodules, or you can put them wherever you need in your particular projects. Next, the topic is about using colors and dimensions and how they get defined. So a lot of people are going for approaches such as this one, where whenever we're using, we're defining a color in the colors XML file, we kind of say a button foreground is FFF, whatever, like 2A, whatever number, whatever color that is. And this is not a great approach because it's really hard to keep track of. And whenever we need to change something, we'll need to change that, for example, blue, the blue background, we need to change it in 5 places throughout the app. So my suggestion would be that there should be nothing in in the colors XML file other than mappings from a color name to an RGB value. Basically, we need to use the color XML file as a palette. This helps avoiding repeating these RGB values, and as such, it will make it easy to change or refactor colors later. Also, it will make it a bit more explicit about how different colors are being used. So, for example, here we know that the color that I just mentioned over there, we actually now know it's a brand. Our brand's blue. You can actually use whatever name you want there. Typically, I would ask the designer of the application for this palette. And the names don't need to be plain colors names such as green and blue. As you can see here, you can also use brand primary or brand blue or whatever fits your project. Then you can also reference the color palette from the styles. So you can actually define also some specialized color for certain cases. But as you can see here, we're not defining the button foreground as a color directly. We're actually linking another color. This keeps our goal of easy refactoring in place. Lastly, in styles XML, we can actually define styles which reference the color palette. And also this reflects the color usage. Overall, this approach offers an improved color refactoring and a much more stable style definition, especially when multiple related styles share similar color or usage properties. We could also say a very similar thing about the dimensions. My recommendation would be that you should always define a palette and with typical spacing and font sizes and so on, for basically the same purpose as we've just mentioned before. So in an example such as this one, we would define the typical font sizes, we will define the typical spacings, the typical size of certain views, and based on this, inside all our style or like layout files or style files, by using these, we will have great benefit from for refactoring, and also much more semantical meaning on what each of these values actually represents. Then moving forward, the goal is to discuss a bit about theming and styling. And one of the most important bits here is that themes are different from styles, and each of them has a different purpose. Styles are actually a collection of view attributes. And in style files, we should basically just define how, let's say, main button looks like, or a secondary button looks like, or a large paragraph or a heading looks like. These are basically attributes for different types of views. Then themes should be collections of named resources, and these should be basically used broadly across apps. This is a huge topic by itself, so I'll go for a very simple example so far. So let's say we're going to define our My App theme, and in here we should probably start by defining each of these attributes, such as color primary, color secondary, accent color, whatever. One cool trick is that you can also use custom attributes, and you can define whatever items here. Like if I don't have an example for this in the slides, but you can go in the attr file, attr file, and basically define some attributes there, such as background color, or like secondary screen background color, or whatever sidebar color, and then basically define it in the theme. The advantages for doing something like this are multiple. So first of all, this works really great because you have a nice overview of which are the important colors, which are the important semantics of each of these things. Secondly, this has great support for doing apps which have themes. So for example, if you have an app where you want to support both dark mode and like normal mode, light mode, then things will work correctly, and that's actually the right approach to doing the dark light mode, by having a theme for the dark, where you actually override the color primary and color secondary with the right values for the dark theme. Secondly, like another very good use case, which is one that you're using, is if you're building an app which actually is, let's say, how is it called, like white labeled app, where you're basically using the same source code. You kind of deploy two versions of the app, like let's say one for a car brand, one for another car brand, or something along the lines of that. So once we have defined attributes such as that, we can actually use them in our layout by their attr values. So rather than saying that this frame layout has a @color / surface color, I'm actually saying that the background of this frame layout is based on the value of this particular attribute. And kind of the same thing for text appearance. We can define, like, here we've actually, it's like a meta thing, but basically we have defined an attribute which actually defines the style of a particular headline. So that means that in a particular theme, we can define a style of headline, like fifth level headline, and then in a dark mode or in a separate app, like separate theme of the app, we can like change the font, or like do a lot of different things based on that. As I mentioned, like, this is a huge topic by itself. So I'm not gonna go into all the details on this, especially after such a long day as today. So I'll just be referencing this link. It's one of the best articles I've read on the topic. It's by Nick Butcher. By the way, at the end, I will be sharing my links, the link to the slides on the chat. So no need to write down now. You'll be able to like explore the presentation and get these links. But I highly suggest you read this, and especially when starting an app, this definitely has a big benefit to basically start designing your resources, your themes from the beginning, because it will make your life easier both at the beginning and also later on when you need to refactor or you need to restyle anything, or for example, like have to implement dark mode while you start just with light mode. All right, so this has been the section about like resources, and next we're going to go very quickly through a couple of tools that we are using in most of our apps, maybe if not all of the apps, and tools that I personally think should be part of the toolbox for every Android developer. To start with, you probably know that memory leaks are something really bad affecting apps, and that's usually really hard to track down. And the biggest issue, if you ask me, is that typically in a fast develop process, memory leaks don't actually are that visible. So for example, when you deploy and then you rebuild and you start the process again every 5 minutes, you're not going to actually see the side effects from leaks. While in production, if the users have been using your app for like tens of minutes or hours or so on, for them, basically, if you leak your memory, the memory usage of your app will rise and rise and rise, and eventually Android will end up killing it. So Leak Canary is a memory leak detection that's really easy to use. You just need to make sure you install it and like pull in the dependency, and then it's going to provide these nice notifications with a lot of information whenever it detects a memory leak. So I would highly recommend you use this in the apps that you build. Secondly, there's Chucker. Very similar to the way Leak Canary works. Just by installing this and like pulling in the dependency, you can have this very nice inspector that's like as part of your app that shows both HTTP messages, so both requests and responses, and also throwables. This happens, so for example, whenever a web request happens in your app, there's a like a push notification. Actually, it's a normal notification that pops up in the status bar, and then just by navigating to it, you can just see what the network request was, what the exception was, and so on. And this is extremely beneficial for the QA team, because typically they run a release build, they don't run a debug build, so it's harder for them to figure out what's going on. So this is the most practical use case we have. We put Chucker in all the apps. So when the app is shipped to the QA team, if they stumble across a problem, or basically they hit an exception, they can actually see the exception, and we actually get the stack trace. And furthermore, they can also like sometimes investigate things by themselves. So they look into what the request response was, and then maybe figure out it's not a mobile app problem, it's a server-side issue. So I highly recommend using this, because it's definitely going to make your lives much, much easier. Moving forward, there's this screen copy. I think that's the way you spell it. So this is an app that's built by the guys from Genymotion, which helps us to share the screen of our device to a computer. It can be a Mac, it can be a Linux machine, a Windows machine, no matter what. So probably some of you have already heard of Visor. That was like a much older way of doing things. However, that system over time got more like bloated with more like ads and everything like that. So recently, the guys from Genymotion, they actually made this screen copy tool, which works extremely nice, and it allows you to basically screen share the screen of your mobile device, and also control it. So just through this window, you can just click around and like do demos, record videos, do whatever you kind of need for your project. Moving forward, probably most of you are already very familiar with this, but since you need to, like, if you need to implement animations, Lottie is one of the tools that I highly, highly recommend. It's a library, I think it's made by the Airbnb team, and the upside is that as developers, we don't actually need to write any animation code. By asking the designers to export their After Effects animations to a special JSON file, we can just import that particular JSON file that they've exported, and then Lottie takes care of the rest. And furthermore, this actually works very nicely on both Android, iOS, and web as well. So we end up with the same animation for all the platforms, which is really, really great, besides the effort that it takes away from us. Lastly, on this section, I have this Android Asset Studio, in case you're not familiar with it. Basically, it's a website where all the generation of assets that are needed for the app is basically simplified. It's a tool, for example, where you can like cut some resources, or like create an app icon, or for example, do these nice shape-shifting vector animations, all that. By the way, these yellow headers, like that's why they're yellow. Basically, they're links. So I have links for everything that you've seen so far. So once I share the presentation, feel free to like navigate through that and like make use of it in your app. Lastly, I just had a very quick list. I'm not going to go in detail to them, but this is a list of the tools that we're using every day in our apps. I am almost confident that almost all of them are used in all the apps that we're we're building. So retrofit, I guess everyone knows, but definitely one of the right ways to do HTTP clients. Picasso is an image loading and caching framework. Alternatives are like Glide or Volley. I think they're pretty good as well. Coin goes for like a dependency injection engine of choice. This kind of is very nice because it's like simplified, it's lightweight, it's less powerful than Dagger, but it works really well for most of the apps which don't actually need all the power from Dagger. Then Moshi is also a really nice JSON library which simplifies parsing. It's been built specifically for Kotlin and works extremely nice with the latest tools that we have. Lastly, we have Timber, which is a highly recommended logging framework. Basically, just by writing like timber.d or debug, you get a log message which has all the information that you would need in there. And then for testing, there's Mock KKK, or like 2Ks, which is a mocking library for Kotlin, which allows us to basically also mock stuff like companion objects or extension functions, which is really nice for Kotlin-based unit testing or testing. These are the topics that I had in mind for today. As a final note, one thing that I highly suggest is you always find the right things and the right tools for your particular project and for your particular job. There are many ways to do things, but there's usually fewer ways to doing these things right. And the second point is that sometimes, even though it brings a little bit of hassle at the beginning of a project, sometimes setting things right from the beginning will actually make your lives much better later on, and will simplify and keep things simpler in the next months. That being said, thank you so much for being here today, and I am wondering if you guys have any questions.